Hi guys, welcome back for another chemistry lesson. In this video, we're going to talk about how to name acids, and I'm specifically talking about just the more simple acids that you're going to come across in general chemistry. So there are two kinds of acids that you need to know. The first one is binary acids. The second one are oxyacids. So binary acids, as the name indicates, are only going to have two types of atoms in the formula: a hydrogen that will pop off as a hydrogen cation, and then a nonmetal that will be left behind as a nonmetal anion, right? So in order to name these, the first thing we're going to do is write down hydro as a prefix. Then we use the base of the nonmetal as the next piece, and then we change the ending of the nonmetal name to IC, and then you will add the word acid at the end. So this first one here, always start with hydro. The base for sulfur is sulfur. So sulfur, change the ending to IC, acid, hydrosulfuric acid. All right, this second one, we start with hydro. F is fluorine, so the base for that is fluor. Then we will add IC at the end and the word acid, hydrofluoric acid. And then for this third one, HBr, we've got hydro. Br is bromine, so the base will be brome. Change the ending to IC. And acid, hydrobromic acid. So you'll notice that they all have this hydro in there. That's very important. That's one of the distinguishing features and ways to tell a difference, because there are some oxyacids that are very similar in name. So that hydro piece is very important. All right. You'll see one here in just a minute that's very similar. All right, so our oxyacids have an H plus cation and then a polyatomic ion that has oxygen in it. So to name these, we don't use hydro. We just look at the name of our polyatomic ion and change the ending of it according to what the ending is on our polyatomic ion. So, polyatomic ion here, this is chlorate. Because it ends in ATE, we are going to change the ending to IC. So this is going to be chloric acid. All right, this guy is our acetate ion. It ends in ATE, so we change the ending to IC. So this would be acetic acid. Here's the one that's very similar to what we were just talking about. SO4 is sulfate. That's going to be sulfuric acid. Notice we had one previously that was hydrosulfuric acid. That's how you tell the difference. If it's hydro, it is a binary acid. All right, and then this last one here that I've got written down, this is a phosphate. So this would be phosphoric acid. Now, all of these ended in IC. So I'm going to give you an example here that does not end in IC. All right, H2SO3. This is sulfite. If it ends in ITE, we change the ending to OUS. So instead of sulfuric acid, this would be sulfurous acid. And then when we are going from name to formula, keep in mind that whenever we have something that the name ends in acid, there's always going to be a formula starting with an H, and we'll have some sort of anion in it, right? If, hold on, back it up. You're always going to write the formula as if it was ionic, even though these are technically molecular, because they have all nonmetals. We're not looking at prefixes for numbers like we would with naming some sort of molecular compound. We are doing it based on charges and things. That's what I mean here. All right. Then if hydro is present, that indicates that this is a binary acid. If there is no prefix present, that means that this is an oxyacid, which again, reflect on what I said in the previous section. Ending in IC means that it's an 8. Ending in OUS means that it's ending in an ite. So sulfurous acid. There is no hydro, so it is not binary. So it is going to be, let's see, OUS tells us that it's going to be ITE, so sulfite. So we'll have hydrogens, sulfite, and then we have to, do the switcheroo in order to get our subscripts. So H2SO3. Nitrous acid. Again, we have no hydro, so it's not a binary acid. We end in OUS, which means that it's an ITE. So it's not nitrate, it's nitrite, which is NO2, 1 minus. And these two things cancel out, so HNO2. Now here, hydrofluoric acid, we have hydro, which means H, and we just have to use this other piece to figure out what the other element is. So fluor is the base for fluorine, which is 1 minus. So overall, my formula is HF. And that's it for naming binary acids and oxyacids.